You touched on this earlier, but do we know what role genetics really plays in cancer? Some people, have a family history of it, and are they doomed to kind of have that repeated in them?
No, first of all. So genetics, in most cancers across the board, about 5% of cancers are due to an inherited genetic defect. In breast cancer, because of the BRCA mutation, it goes up to about 10%, which means the majority of cancers are not due to an inherited genetic defect. What we've learned recently is that there's this very fascinating kind of phenomenon called epigenetics. And this has to do with not so much changes in the DNA or the genes themselves, but changes in the way those genes express. So at any given time in every cell, certain genes are silenced and certain genes are sort of turned on.
Right.
And that pattern of silencing and being turned on will influence not only the cell, but very particularly will influence cell repair, and or will cause certain growth genes to be overactive, which would be called a tumor promoter gene. So what we know now is that how we live our life has a lot of influence on the gene expression, the pattern of turning those on and off. And in fact, some of that patterning we get epigenetically through the way our parents lived. It's actually that pattern of genes turning on and off actually happens, is passed on from generation to generation. And then we further modify it in our own lifestyle. So there is an element of inherited risk, but not due to genetics per se, but more to genetic expression. And that's kind of good news because we also know that how we live our life has a huge influence on genetic expression. So that actually is why I think most of the therapies that we associate with prevention work, because they're actually changing genetic expression patterns. And this really opens up tremendous opportunity for us to create prevention effects.